root or any even root requires positive or 0 underneath, but if it's in the denominator, not 0, of course. So for now, since it's not in the denominator, then I have to write this. How do I solve this, and what is it, first of all? What is this? Yes, very good. Which type? Because it depends on which type, because I don't know how to proceed if I don't identify it correctly. What type of inequality is this? That's the inequality. What type? What is this? Yes, what type of function? Very good. It's a quadratic inequality. How do I solve a quadratic inequality? What do I need to do? I cannot take square roots from an inequality. Not allowed. Never. Never. I cannot take square roots from an inequality.
Oh, right. You can change x squared to absolute.
I could do that, but there is an easier way. You're right. So first of all, I will multiply by -1. It's not in descending order. I don't like the way it looks. So x squared minus 16 less than or equal to 0. What will be the next step? We know two big key words in this class and in all math classes. Exactly. So which one is it? Good. So how do I factor? We have an agreement on the first day of classes. We know how to handle this. We have an agreement. Anyone? Very good. Good. So now I have to study the sign. Study the sign of this, of x plus 4 times x minus 4. If you like my method, use it. If you have a different one, congratulations, use it. So negative infinity to infinity. The point I'm making is I'm fine with any method. I prefer this one because it's easier to explain. I don't have to plug in numbers and so on and so forth, but please feel free to use the one you like. So I'm studying the sign of this expression, and I see that this has a 0 at -4 and this has a 0 at 4. Therefore, the product will be 0 whenever one of the factors is 0. Now, what type of functions are these? With a positive slope or with a negative slope? Will these two look like this or like this? Positive. Okay, so they come from which values? Negative, and they go to which values? Good. That's all I need. So it's coming from negative and going to positive. Coming from negative, going to positive. So what is the sign of the expression when I multiply two negative numbers? What is the sign of the expression when I multiply a positive by a negative? And what is the sign of the expression when I multiply two positives? Good. Finally, I'm looking here. Which sign is less than or equal to 0? There is only one sign that is less than or equal to 0. Negative. Is this product ever negative? Right here. Which means for which x values? Perfect. So I will say domain -4, 4. Do I close? Do I leave it open? Parentheses, brackets? What do I put? Very good. 0 is accepted. Good. So this is the domain. After all this work, all I found is just the domain. Okay. So now I'm saying I can answer this question. 4 from the left, the square root of 16 minus x squared. Is 4 from the left in the domain? Good. So what is the answer? Because if it were in the domain, I would have written D and E right away. But 4 from the left is 3.9, and 3.9 is in the domain. So the answer is 0. Any questions? Okay, the next one. We had this so many times, rationalizing numerator or denominator. In this case, numerator. I think we're okay with this, right? We rationalize the top with the square root of 1 plus h plus 1, right? Top and bottom. Is this okay? Okay. Number 7. It's 1 over 0, which can have 3 options. It can have infinity, negative infinity, or D and E. I know this graph, and we all have to remember this graph. This is the graph of 1 over x. As x approaches 0 from either side, from the right, remember you have to look at both. From the right is, from the left is. So what is the answer then? Okay, the greatest integer function, it's a step. So as x approaches 2 from either side, this is 1. Of course, the limit from the right is 2. The limit from the left is 1. So this will be D and E. We will discuss this again, this function later. I'm sorry. No, I will not put the greatest integer. I just put it here because I want you to know what it is, and we'll discuss it again.
1 through 7.
I'm sorry.
1 through 7.
Yes, this will be on the exam. All these will be on the exam. Radical function, yes. Rationalizing, yes. D and E, yes. The greatest integer function, we did not graph it. I just gave you an idea of the step. So I will not put the greatest integer function on the test. Now this, how do we handle this type of? We had several of them. How do we handle that? Yes, because if you plug in 0, this does not exist and this does not exist, so you cannot split it. We had this problem in class. You cannot, or similar. You cannot split it into. It's not, the limit of the difference is not the difference of the limits in this case, because one, the most important, the only condition is that the limit of the first function to be a number and the limit of the second function to be a number, and that's not the case here. So you cannot apply the limit law. So what can we do is indeed the least common denominator. So let's give it a shot. Okay, what do you think? I would have to agree if only if you had said to me, factor out 1 over t. So if you do say that to me, then I would agree with that. But if you don't say factor out 1 over t, then the least common denominator must be t multiplied by the square root of 1 plus t. But I like the idea of factoring out 1 over t.
That's what I mean.
Oh, I'm so sorry. Forgive me. I didn't hear it well then. So in that case, 0 here. So limit as t approaches 0, 1 over t, and the least common denominator is 1 over square root of 1 plus t. What do I have at the top? And what is the adjustment for this function? Fraction, I meant to say. What is the adjustment here? Right, excellent. So can anyone give us the top of this fraction? There's not 1 over. I just need the top. Exactly. Very good. Now I'm ready to plug in 0 to see what this is. So when you plug in 0, what do you get? The top is 0. The bottom is 0. So there's a t in front here. However, this is not a factoring situation. There is no factor of t that goes out from the top and a factor of t to 0 because the situation is different. Of course, I will leave this alone. This is not the problem, right? So I will get eventually to simplify, but right now I can't because I can factor t out of here. I do have a t. Leave this one alone. This one is the problem, but I have to do something else to this, which is what something else? Exactly, the conjugate of the numerator. So I have to multiply by 1 plus, so that goes away, 1 plus the square root of 1 plus t, and 1 plus the square root of 1 plus t indeed. This one, leave it alone. Limit t approaches 0. 1 divided by the square root of 1 plus t. This is not the problem. This is friendly. And then I have 1 over t multiplied by 1 plus the square root of 1 plus t. And what do I have at the top? And that's why we had that agreement. First day of classes. So what do I get at the top? Say it again. The first term squared, which is 1, minus the second term squared, which is the second term squared. I'm squaring a square root. When I square a square root, what do I get? Exactly. There's not 2 because you have to distribute. That's why I was waiting. Is that clear? Yes? So limit t approaches 0, 1 over the square root of 1 plus t. The top is 1 minus minus t divided by t. And now I know that's what has to go away. That was the problem. But this, from the beginning, this was not a factoring situation. So I couldn't pull out that factor. I had to rationalize first. And now I can't get rid of it. So I will get rid of t, and it's done. Because the problem is out of the picture. So now please tell me the limit. There is a negative and there is a 1. So negative 1 over. This approaches 1 and this approaches indeed 2. So 1 times 2. Very good. It's a lot of work with these limits. And there are so many different types. So many different types. Okay, let's go to the second page. Okay. I'll get another handout so we can see what's here. Okay. This is a yes for the test. This is a yes for the test. This is a yes for the test. And of course, we're going to look at the rest. Okay, ready? So limit x to the 4th, cosine 2 over x, as x approaches 0 from either side. Okay, 2 over 0. Remember the function? We just graphed it a minute ago. 1 over x or 2 over x. Okay, no, it's right here on the handout. 1 over x or 2 over x is the same thing. Very close. So then 2 over x as x approaches 0 is dne. Cosine of dne. Cosine of dne times 0. I have no idea. So what do we do in this particular situation? Anyone remembers? It's right there on the handout. It's the title of that section. Right. So where do I start? Yes? In the middle of what? Nope. What do we know about cosine?
It has to be
Excellent. Cosine is a bounded function, can never exceed 1. It can never go below -1. Excellent. So I already built this piece, but that's not enough because that's not the entire function. What do I want to do next? Multiply by x to the 4th. Is x to the 4th a positive number always? Because if it's not positive, I'm in trouble. Because if I don't know whether it's positive or negative, then I don't know when to switch the inequality symbols. So I have to think, is x to the 4th always positive? Is x to the 4th 0? Because if x to the 4th is all positive, I can multiply all 3 sides by x to the 4th. But I'm in trouble, again, if x to the 4th can be 0. Can x to the 4th be 0? I cannot multiply all 3 sides of a compound inequality by 0. Can x to the 4th be 0? The answer is no. Because x approaches 0 specifically says,
so it does.
exactly, this specifically says x not equal 0. When we say x approaches 0, we really mean it. Approaches, not equal to. So I'm safe. This is greater than 0. So I'm safe. The inequality symbols do not change. And it's not 0. So I'm safe again because I'm not multiplying by 0. Are you with me? Perfect. So then I have negative x to the 4th less than or equal to x to the 4th times cosine 2 over x less than or equal to x to the 4th. Now, what? What am I showing? I'm showing the sandwich. So our function, which is this, let me, I don't know, call it g of x, is squeezed between near 0. I don't care what happens way outside of that small interval around 0. It's squeezed between f of x and h of x. This is the first hypothesis of what? The squeezing theorem. Right. I have to show that there are 2 functions, one top and one bottom. And I did. I found the bottom one and I found the upper one. Now what? What is the second hypothesis? That the limit of f of x as x approaches 0 exists, and in this case is, and then the limit of h of x as x approaches 0 exists and is. They both exist, the limit from f of x and the limit of h of x both exist, and the numbers are the same. And that's the second, let's write it. Limit from negative x to the 4th as x approaches 0 from either side equals limit of x to the 4th as x approaches 0 from either side. And they are both the same. Not just they exist, but they're also the same. What do I conclude from 1 and 2? What is my conclusion from 1 and 2 by the squeeze theorem? What is it? Yes, is indeed 0. But I have to show both conditions, or I should say both hypotheses, that the function is squeezed and that both limits of those two functions exist and are the same. Then I can conclude that the limit of x to the fourth cosine 2 over x is 0. I think we had on the quiz last time a problem like this. I think we're okay with that. Here, if you want, we can look at this problem. I wanted to refresh your memory on some exponentials and logs. The inverse trig other than arctangent, which I would like to go through. The hyperbolic functions, we discussed them, but I would like to wait till we get more. We have not talked about this. This does not come into play till chapter 3. So we do have those 7 indeterminate cases. So this is not for us right now, not right now. So we have those 7 indeterminate cases in which no conclusion can be made from the get-go. We have to work on the problem till so we do not know this just yet, okay? We do not know this just yet either. So these are not for us right now. This is the entire handout. We're not going to be able to, we don't have enough information just yet. We will. As the semester progresses, we will be able to do these. So I like to look at a couple here. But also tell me what else you need from here. I still have time, yes. So do we need to work on this particular limits to infinity? So when x approaches infinity, what happens? Yes? Okay, so let's take a look. We've done something like this before. So let's look at this problem. Limit as x approaches infinity, 2x squared minus 5 divided by x squared minus 2. Here's a question for you. When I determine the limit left and right, or either side, only from the right or only from the left or from either side of a number, and I get infinity, what does that mean? That the function has a vertical asymptote, clear. Now what if I determine the limit at infinity or negative infinity and I get 15? What does that mean? Horizontal asymptote, y equals 15. Okay, good. So keep that in mind. So if here I get infinity, it's a vertical asymptote. If here I get a number, it's a horizontal asymptote. Okay, perfect. So what do I do here? I plug it in, and I have infinity over infinity. This is one of those that we already observed. We observed before infinity minus infinity, and we rationalized it. We observed 0 over 0 and infinity over infinity. We did not have any encounter with the other 4 yet. Okay, so it's infinity over infinity. How do I proceed? I look at the top and I say, oh, the degree is squared. I will factor out the degree. I will look at the bottom and I realize the degree is 2. I will factor out x squared. Now carefully tell me what to write in parentheses. And how many terms will you give me? Very good. And the bottom? Do we all agree with this? Okay, but I do know, careful, when x approaches infinity, I know where this is going. And of course I will simplify, I forgot to mention that, of course. And I know where this is going. 5 over infinity. I have $5 and I want to share it with everyone on the planet. When I knock on your door, how much will you get? Nothing. You will not get anything. By the time I get to you, if I start with China and India, you will get nothing. You will get nothing by the time I finish with them all. 5 divided by infinity, 0, 0. So what is the limit? 2 over 1. So what does this mean? What does that tells us about the function? Y equals 2 horizontal asymptote. It's at both ends because I did not use positive or negative infinity. So it will be a horizontal asymptote both sides. Any questions? Okay, so let's look at the exponential functions. There's a lot here. I would like to look at, these are a little bit for later. This is a little bit later. So let's just look at these two. Okay, so let's look at limit from e to 2x minus 1 over e to x minus 1 as x approaches 0. Now, if you want to take just 1 second break before we do this, and just open your book, let's say on at the end of 2.1 for a second, if you want to share, if you have your book and your colleague doesn't. Or you know what, let me show like the same thing. So let's just take a break from limits for 1 second. I just show you. What can I ask from section 2.1? What could I ask? Something like this. That's all I can ask from section 2.1. I would rather ask you to find the derivative of the function or the instantaneous velocity directly, but from section 2.1, that's pretty much all I can ask. A problem like this, in which you plug in some numbers and you estimate the instantaneous velocity. Okay? What can I ask from section 2.2? I can give a graph, right, and ask you to find the limits. I can ask you to graph a piecewise defined function and answer some questions. That's pretty much it. And again, limits that we are just looking at and reviewing everything. What can I ask in 2.3? Right, common sense. In 2.3, just limits. Squeezing theorem. Limits again, this was one of the limits that we looked at, and I also have it on the handout. I really liked it. And that's pretty much it. And of course, the limit laws. So you have to remember, and remember this is very important, these two limits have to exist. If they don't exist, I cannot say that the limit of the product is the product of the limits. I cannot say that the limit of the ratio is the ratio of the limits. They must be numbers. And in this case, the limit cannot, the denominator cannot even be 0. Okay, so that's pretty much what I can ask from 2.3. There's nothing else. From 2.4, a simple linear, just linear inequality limit of a linear function to show it with a precise definition or the epsilon delta definition. Okay, from continuity, this is extremely important. I may ask you to graph a piecewise defined function or try to find the parameters or the unknowns as we had on the quiz, such that the function is continuous everywhere. And remember, at the very end, you have to plug it back in and say, hey, I found the numbers, this is it. This is the function that is continuous everywhere. So that's pretty much it in continuity. And of course, the intermediate value theorem. Don't forget this. This is very important. In which, what will you say? The function is continuous on the interval that I determined. You have to plug it in the calculator and see where it changes sign, but you have to say it's continuous as a combination, addition, subtraction of continuous functions, and show that it changes sign. Therefore, you will say there must be a number c in the interval such and such where the function crosses the x-axis, or where the equation has a solution. But remember to create the function, right? We can do a problem like that in a minute. What else can I ask here? We are just doing that right now. Limits at infinities. We just did this right now. All these limits. Also, before the end of the day, I want to show a problem. You had homework. Nobody asked about this, but I would like to pick a problem from here. So that's pretty much it. And yes, a problem in which we're asked to find the horizontal and the vertical asymptotes. But you have to also show the limits. You cannot just say, oh, I know that this function has y equals to a horizontal asymptote. You have to show the limits. Okay? And you can say the limits are the same. So here we have those two definitions for f prime of a. Just a couple of functions, please look at that. And the last one, 2.8, exactly what Ben asked at the beginning of the class today, like problem 25. We just did that. Okay, that's pretty much it. Okay, so we're back here. When I plug in 0, what do I get at the top? Yes, because e to 0 is 1, 1 minus 1 is 0. And what do I get in the denominator? I agree. 0 indeed. Okay, this is another situation in which I could factor, but you may not see how to factor this. You may not see how to factor this. Here's another way. This is factorable because you can change it into this, which you can change it into this. But let's say we don't see that. What is the other way? Okay, here's the other way. I will factor out e to 2x. And I will factor out e to x. If I factor e to 2x at the top, like we just did with this, pretty similar. Pretty similar. What do I have in parentheses and what do I have in parentheses? Very good. Yes? Say it again. Exactly. 1 over e to 2x. So whatever you put in here, take a moment and check. This times this is this. This times this is this. Good. So then it's correct. Now about the denominator. What do I have left in parentheses in the denominator? Very good. Perfect. Okay. Leave this for a moment alone. Now please tell me what happens when x approaches 0 here. For some reason, here's my error. I was thinking that this approaches infinity, and I was going to say that this is 0, this is 0. But I made a mistake. It's approaching 0, not infinity. Sorry. So this is my way. For a second, I thought that this was approaching infinity. In this case, it's still 1 minus 1 and 1 minus 1, and I didn't get rid of the problem. Sorry about that. And for 1 second, I thought it was infinity. So this is my way. Sorry. So this is limit as x approaches 0, a to the x plus 1, e to the x minus 1 divided by e to the x minus 1. In this case, it's the only way. Can't think of another way. For a second, in my mind, I had infinity. So I will definitely simplify these two, and the answer is yes. E to 0 is 1, 1 plus 1 is 2. Sorry about that. Good. So let's see. Is there anything else that catches our eye here? Yes, let's also look at this one. These two limits actually come from one of my colleagues. He also has a handout with limits, and he put these limits on his handout, and I said, yeah, interesting. So that's why I put them in here. So those two were not selected by me. So limit as x approaches infinity, e to 1 over x plus e to negative 1 over x divided by e to 1 over x minus e to negative 1 over x. So I plug in 0 and it's a total mess. Okay, what can be done here? Let's think for a moment. I'm going to try to simplify this function a little bit, see what we get. So this will be e to 1 over x plus 1 over e to 1 over x. And this will be e to 1 over x minus 1 over e to 1 over x. So what do you think will follow next? Give an idea. And I can give you a hint. What am I telling you? The least common denominator, 1 over x, e to 1 over x, and e to 1 over x. So what do we get at the top? Yes, exactly. E to 2 over x plus 1. Because when I multiply e to 1 over x by e to 1 over x, I have to copy the base and add the exponents. And 1 over x plus 1 over x is 2 over x. I will not, I repeat, I will not put a problem like this on the test. Okay, so again the same thing, e to 1 over x. So it's e to 2 over x minus 1. Let's see if I accomplished anything. Maybe, maybe not. I did accomplish one thing, that I will simplify these two because I have to flip. I copy the numerator, I flip the denominator, and these two will go away. So the next step, as x approaches 0, e to 2 over x plus 1 over e to 2 over x minus 1. Okay. What do you think we are going to do next? Nope. No, this is not a radical. So I will factor out like I did before, but this will be a different story. One thing that I want to say, you may look at a limit and say, gee, I don't think I know what to do to it or to the function. I want you to think about it and I want you to try it. Try something. Something will come to you if you're looking at the limit or the function and think about it a little bit. If it has a radical, if it can be factored, if it can be, if something like this I can factor out like we did here, x squared in the infinity over infinity. Try something. Something will come to you. Okay, so this is 1 plus 1 over e to 2 over x, and this is 1 minus 1 over e to 2 over x. Yes, this situation is different than the previous one, in which here, when x approaches 0, this is 1 over 1, and that's how I got in trouble, because this is still 0. I didn't clear it. But this is a different story, because the exponent is 2 over x. So these two go away. Now let's analyze what happens to e to 2 over x. As x approaches 0, what does 2 over x do? It either goes to infinity from one side, or it goes to negative infinity from the other. So I think he probably made a mistake. He probably thought of either side, because it won't work. I have to look at both. I have to look at both now, since it approaches 0. So I have to look from the left, which will be positive infinity, and I have to look from the right, which will be negative infinity. So if it is from the right, this e to infinity approaches infinity. Therefore, this will approach 0. So say it again. So then the limit will be 1. And I have to say if x approaches 0 from the right. But I also have to discuss the situation in which x approaches 0 from the left. So if x approaches 0 from the left, then 2 over 0 will approach negative infinity. And this expression will approach infinity, not 0. Because e to negative 2x goes to the numerator. So then I have to analyze what happens in that case, and then I will have to factor differently. So for now, I'm just going to say, because I don't want to extend this, I have other important things to do with you. So I'm just going to say this just from the right-hand side. And we can, next time after I return the tests, we can talk about this one and see what happens. But this is definitely from the positive side. Since it's from either side, I have to determine both. So if x approaches 0 from the left, then this will approach infinity and this will approach infinity. So I have to handle factoring and everything else differently. Okay, so we can, remind me, I don't want to forget about this. So e to 2 over x plus 1 over e to 2 over x minus 1 when x approaches 0 from the left. We may get the same thing. I don't know. I have to look at it. Okay, so the other thing that I would like to look at with you is a problem in which we are told to come up with a function that does this, or complies with different conditions. I know you had this on homework. Nobody asked, because we can't do every type of problem, but since we have the test on Wednesday, I want to go over at least one problem. Yes, on page 140, so let's choose. Page 140, problems 5 through 10. Sketch the graph of an example of a function f that satisfies all of the given conditions. So I want you to choose whatever you want. Which one? 6. 6 it is. Okay. So let's look at problem 6. So I'll say here, come back. Please remind me when I return the test. Or sometime, maybe you want to discuss this before we start the test. That's fine too. Okay, so we are looking at problem 6 on page 140. Let's read the problem. I'm going to copy my information. So I'm told that limit of f of x as x approaches 2 from either side is infinity. I am told that limit of f of x as x approaches negative 2 from the right is infinity. We also have that, oops, I only have 1 minute left. Limit as x approaches negative 2 from the left of f of x is negative infinity. Limit of f of x is 0 when x approaches negative infinity. Limit of f of x as x approaches infinity is 0, and f of 0 is 0. Okay. There's no time in this class to do much. Okay. So here's what I recommend. Of course, you can use the method you like. As x approaches 2, say here's 2, the limit from either side is infinity. I took this into account. The limit from f of x as x approaches negative 2 from the right is infinity. Done. Negative 2 from the left is negative infinity. I put parentheses because these are infinities are not numbers. Done. And as the limit of f of x as x approaches negative infinity is 0. So negative infinity is 0 here. Done. Limit of f of x as x approaches infinity, 0. Done. which tells me that y equals 0, horizontal asymptote at positive or negative infinity. And I'm told that f of 0 is 0. Done. I have all my information in the chart, and I'm ready to create a graph, any graph that fulfills with the given conditions. So here's my graph. Good. So this is a horizontal asymptote. I know this is redundant. So y equals 0. At negative 2, 1, it must be a vertical asymptote. X equals negative 2 must be a vertical asymptote because on the left-hand side, the function goes to negative infinity. It approaches 0. Let me use a different color. It approaches 0 and negative infinity. 0 as x approaches negative infinity, and negative infinity on the left-hand side of negative 2. On the other side, it approaches 0. So there is a point at 0, 0. It approaches infinity as x approaches negative 2. The function approaches 0. It has to cross at 0, 0. It has a vertical asymptote, no question about it, at 2. So x equals negative 2 and x equals 2 must be vertical asymptotes. Here it approaches infinity. No question about it. On the other side, it's coming from positive infinity and goes to 0. So this is an example of a function that complies with all